All right, hello. Thank you for watching this video. I'm making this video mostly for my students' sake. This video is going to be on polynomial functions. So first off, what is a polynomial function? A polynomial function involves, oh, maybe I should put that in there, involves only non-negative integer powers of the variables. So we're talking about variables that have non-negative integer powers. And I put here powers, we're looking at the exponents, that's what a power is. So something with an exponent of 2 is to the power of 2. Something with an exponent of 3 is to the power of 3. Integers, so integers, right? We're going to start at 0, 1, 2, 3, right? You just continue on of non-negative integer powers, all right? So those are the exponents that we will be looking for. Now, usually starting maybe in pre-algebra, algebra 1, maybe earlier than pre-algebra, pre-algebra, you start actually seeing polynomial functions, except nobody tells you yet that they're polynomials. Or maybe your teacher does. Maybe your teacher does teach that down at the middle school level. But you have constants, linear equations, quadratic equations. Usually those are taught without actually saying, oh, this is a constant polynomial. This is a linear polynomial. This is a quadratic polynomial. Usually what you see is a constant polynomial is just like y equals 4. That is a polynomial equation, all right? A linear equation would be something like y equals 2x plus 4, where now we have a degree of, technically there's an invisible 1 there, that's x to the first power. And technically this is actually x to the 0 power, but anything to the 0 power would just be 4 times 1, which is just 4. So technically even here, this is actually x to the 0 power. We just don't write it there because x to the 0 power, anything to the 0 power is 1. So really it's just an invisible 1 there. 4 times 1 is 4. We don't need to write it. And then, so that's y equals mx plus b. Normally you get taught, oh, hey, let's do slope-intercept form. You're not taught that that's a polynomial until you get to that. And then we work it in that that's a polynomial. You actually have been working with polynomials. Quadratic equations, y equals, I don't know, negative 3x squared minus 5x plus 4. Cramming that in there. But right, we have the exponent or degree or power. So by the way, power, exponent, degree, these are all the same. These are all interchangeable. Exponent, power, degree, those are all the same thing. All right, now what you're looking at is you're looking at, oh, the highest exponent or the highest degree is 2. So now it's a quadratic equation. We're squaring things, right? And then the cubic, you have an exponent of 3. The highest exponent is 3. The highest exponent is 4. The highest exponent is 5. After that, usually I would say that for my students personally, I've gone constant, linear, quadratic, cubic, quartic, quintic. And then after that, if it has a 6th degree or anything, they just say nth degree. So it'd be 7th degree polynomial, 12th degree polynomial, 10th degree polynomial, 99th degree polynomial. Now, sometimes they're not called polynomials though. I know this is a whole lot of information to start off with. Makes a lot more sense, and I'm going to go through examples in this video. So if you want to skip straight to the example, skip straight to the examples. But a polynomial, sometimes we're not going to call them polynomials. Sometimes your teacher might want you to call them a monomial, a binomial, a trinomial, or a polynomial. So a monomial, mono, means 1. Bi means 2. Tri means 3. And then poly means multiple. So mono, bi, and tri, 1, 2, 3, and then after that, four terms or more, you're just going to call it a polynomial. If there's 5, 6, 7, 8, 20 terms, you call it a polynomial, starting at 4. And what separates terms out? Addition and subtraction. Addition and subtraction separate terms, all right? Plus or minus separate terms. All right, these are the separators of terms, not multiplication, division, or anything else, plus or minus. Those separate your terms out. So I want to give a few examples before we go into some problems of what are some non-polynomial terms. So some non-polynomial terms. So if I go back up to the definition, polynomial functions involves only non-negative integer powers. Only non-negative integer powers of the variables. So if I look here, is this non-negative power? Is that a non-negative exponent? No, that doesn't work. Now here, something that I talked to my students about today is a square root and a cube root and a fourth root. A root is actually an exponent. And what a root is technically, this is actually 4 times x to the 1/2. So if you don't understand roots, what a root is let's say you have just a random root, nth root, that is actually equal to x to the 1/n. So if it's a square root, technically a square root is, right, x squared, squaring, it's 2, it's an exponent of 2, so it's 1/2. If I had a, I don't know, let's say a cube root of 27x, technically that would equal 27x to the 1/3, because it's a cube root and it goes on the bottom. So again, though, the point of saying that is this an integer? Is 1/2 an integer? No. Integers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Whole numbers. Whole numbers. Integers are whole numbers, whole counting numbers, positive or negative, except for in this case, we're not doing negative. Negative is a no-go. So this is also a no-go. That does not work. Nope. Doesn't work. Here, some students just, it helps them remember that if the variable's on the bottom, it's not a polynomial, it's rational, right? This is a fraction, this is a rational function. Now, why is it? Because technically, what this is this can be rewritten as 2x to the -2. This -2 here actually puts it on the bottom of the fraction. So you can remember it two ways. You can remember it as, oh, this is actually a negative exponent, or you can just remember it as the variables on the bottom. That means it's a rational function, not a polynomial function. The reason why it's on the bottom is because it's a negative exponent, though. And then here, just looking here, that's a no-go. That's not a counting number. It's positive, but it's not a 1, 2, it's 1.4. Doesn't work. Just like this one, it's 1/2. Doesn't work. Okay, so knowing that, let's actually get into the examples. I don't want to talk too much, so let's just hop in. These first questions are determine if the expression even is a polynomial. So just do, because it's hard to see, plus, minus. So is this a polynomial? Is that a positive integer? 5, yes. Is this exponent a positive integer? Yes. Is this exponent a positive integer? Yes. Is this a polynomial? Yes, it is. It is a polynomial. If it is a polynomial, state the type. So you got to find what's the highest degree. The highest degree is 5. So this is a quintic. So this is a quintic. Quintic what? So quintic binomial, monomial, trinomial, polynomial. How many terms are there? So again, addition and subtraction separate terms. So we have 1 term, 2 terms, 3 terms. So this is a quintic trinomial. Right? Why is that? Because it is a 5th degree and it has 3 terms. Right? 5th degree, 3 terms. Quintic trinomial. All right. Determine if this one is. So this one's a little bit trickier. Positive integer, yes. Positive integer, yes. There's actually this other variable here, and it has the fun invisible 1. Technically, this degree is to the first power, but it's still a positive 1, so that works. So we got all positive. So is it a polynomial? Yes, it is a polynomial. The trick here is a lot of students immediately think, oh, it's a cubic. It's a 3rd degree. That's the highest number. That's the highest exponent I see. However, this term, this one right here, the second one, this is a multiplication right there. So you actually have to add up the exponents in a single term. So in this single term right here, there's actually a total of 4, right? 3 plus 1 is 4. So this is actually going to be a quartic mono, bi, tri, or poly. This is a bi. It's got 2 terms. So quartic binomial. Right? Because the highest degree, right? 3 plus 1 equals 4. And binomial, it's got 2 terms. Is this a polynomial? Is this okay? Is this right there okay? No, because technically that's w to the negative 1. Really, if I was to rewrite this, out, I would rewrite this as 8y to the, oh, I can't tell if that's a 3. I think it's a 3 to the w negative 1 plus 5y squared. That's not okay. That is a negative power. That is a negative power. It does not work. All right. So not a polynomial. How about this next one? We run into this issue. That's okay. That's okay. This is not okay because technically that is p to the 1/2. And that is not an integer. That is not a positive integer. It's a positive exponent, but is not a positive integer. All right. So that one, again, is not a polynomial. All right. It's a radical function and a polynomial function. It's just, yeah, it's a conglomerate if you like geology. All right. Moving on. Now these ones are polynomials. We just want to write these polynomials into standard form. So standard form means highest degree to lowest degree. And remember, degree is the same as power or exponent. All the same thing. So descending order. So I like this term, and I got this term, and I got this term. that is actually the leading term, right? This is, because that's the highest degree, that's the leading term, leading term. So I'm going to put negative 5x to the fifth. However, these two terms are not in the right order. This has actually a degree of 0 because there is no variable there. Because remember, when there's a variable, when you have a variable x to the 0, that's equal to 1. And that's not a variable. The 0 makes the power of 0 makes the variable go away. Makes it become a 1. So this actually needs to get moved in front of that one. So we're going to do negative x to the fourth plus 1/8. So a couple things here. Again, this whole thing is the leading term. So this whole thing is the leading term. And this number, this coefficient in front, the number that is in front of the variable that's multiplying the variable, that is the leading coefficient. All right, so the whole thing is a leading term and the front number is a leading coefficient. And then off here to the side, you have the constant. It's got no variable, it's just a constant. Now, if there's not a constant, then the constant is 0, because there's no sense in saying plus 0 or minus 0. All right, so the constant should always be at the back. So I need to move this constant term to the back. So I'm going to get x cubed over 6 plus 1. Now I'm actually going to rewrite this. You don't have to, but I'm going to rewrite this. This is okay if you're to answer this question like this. This is a simplified version. I'm going to rewrite it for the sake of what I want to talk about, though. That this is actually 1/6 x cubed plus 1. All right. And the point of doing that is you can now visually see the leading coefficient. The leading coefficient is 1/6. Not so easy here. Some students mess up with the leading coefficient when it's written like this, but when it's written like this, you can visually see, oh, it's in front of the x cubed. It's 1/6. Because technically there's an invisible 1 right there, because 1 times x cubed is x cubed. So all you're doing is you're taking this 1/6 and putting it out front. All right, next one, I need to take this middle term and move it to the front because that's the highest degree, right? That is the highest degree. So I need to move it to the front. That is going to be my leading term. So I'm going to get negative 10x cubed plus is a positive x squared. So plus x squared minus 1/7. So again, we have the whole leading term, right? That's the leading term. And then you have the leading coefficient. All right. Getting there, almost done. Now I just want to go over some addition and subtraction in there, an area model, box method area model. So now that we've talked about what is a polynomial, how do you name a polynomial, what types of polynomials are there, what is not a polynomial, what's the standard form? This is the standard form of polynomial, right? Highest degree to lowest degree, that's standard form. So this is putting it into standard form, highest to lowest degree. Now I want to talk about doing some operations. Now I'm not going to talk about a ton of multiplication and division of these. That'll be later videos. This is just an introduction video. This is part 1 of a series, most likely. Now, I've been able to give students subtraction problems of polynomials and they were doing just fine with really barely any explanation other than the fact of telling them, hey, you need to combine like terms, and they could subtract them. However, when given them in the form of a sentence, a little bit more of an issue. So if I read this, it says, subtract negative 3x squared plus 4x plus 10 from 2x squared minus 2x. If you're reading that, that's saying that you are going to subtract this from this, not putting just a minus sign there and doing this minus this. You're subtracting this from that. So you're actually subtracting the trinomial from the binomial. Now it's really important that you're putting parentheses around these, not necessarily around the first one, but you have to put parentheses around the second one, especially if you're doing subtraction, unless if you're going to do some distribution in your head, do some mental math. Okay. So the first thing that you can do is distribute this negative to those three terms. So really, this is going to be plus 3x squared. This is going to be minus 4x, and this is going to be minus 10. And then you can just drop down your 2x squared minus 2x. Now the key thing in here is like terms. Like terms. So what can we combine? I'm going to combine the x squared term with the other x squared term. I'm going to combine the x term with the other x term. This one doesn't have something to combine it with, which is okay. You're just not going to combine it with anything. So if I'm going to put this in standard form, I'm going to start with the x squared because that's the highest degree. So 2x squared plus 3x squared is going to be 5x squared. Negative 2x combined with a negative 4x is a negative 6x. And then you just drop the negative 10 down. So that is in standard form with highest degree to lowest degree, right? This is technically going from 2 to 1 to actually x to the 0 out here. So degree of 2, degree of 1, degree of 0. All right. So that's just a version of a worded subtraction problem. Addition, a little bit easier because you don't really have to worry if you're adding from the right thing in the right order. Because you're not going to have to worry about distributing a negative. These symbols just did not print out well. So this is a negative, negative, plus, plus, negative. Okay. So this one's an addition problem, and you can see it like this. So I'm just going to combine like terms again. So negative 2x plus negative 9x squared. So that would be negative 11x squared. And then I got negative 8x plus 1x is negative 7x. And then positive 3 plus positive 3 is 6. And again, just need to remember, we have our leading coefficient. All right. We have the leading term, which is the whole front term. And then do not forget, you have a constant. Then you got your middle terms, but those are just some key ones to remember. Okay, so I'm going to leave, this is the last problem, and this last problem is actually multiplication, specifically of binomials. This is 2 binomials. And I just introduced my students to this today, this area model. It's also, you can call it area model, you can call it multiplication table, polynomials, you can call it the box method, whatever you call it. It's really just a multiplication table, but of polynomials. So you just drop down the binomials, you drop down the first term, so negative 2x in this box, negative 5 in this box, negative 4x here, negative 6 here. And you just multiply it. This is a multiplication table, right? Multiplication, multiply them. So what is negative 4x times negative 2x? What's negative 4 times negative 2? Positive 8. What is x times x? X squared. Now, same thing. What is negative 4 times negative 5? Positive 20, and then x. What is negative 2 times negative 6? Positive 12x. What is negative 5 times negative 6? Positive 30. And then you just combine what you can and write your equation. So this is 8x squared. Combine your x's, plus 32x, and then plus 30. So all you're doing with multiplying this is basically you're taking factored form of a polynomial and multiplying it to be in standard form. Okay, this video ended up being longer than I wanted it to be. So thank you for watching. I sincerely hope this was helpful. And like I said, this will be part 1 of a series on polynomials that my students will be working through. So thank you for watching.